Okay, so hello externals, you can record me. We also recorded parts of this session from last year. Okay, so to bring our externals up to speed, today we're going to talk about code reviews. Can you see my hands? Yep. Code reviews, professional programming, security, and design patterns. So the design patterns, as I discussed with this class, I'm not going to teach you design patterns in this at all. We're going to talk about design patterns. So we're going to start there because they're kind of at the top of the list and something we can discuss. Okay, so design patterns. Go and Google them, you'll find lots of them. The singleton pattern, I was talking to my students earlier today, is the singleton a good or bad pattern to do things? Okay. Now, one of the reasons I asked this is, given that you all know how the singleton pattern works, does someone not know what the singleton pattern is? Okay, so the singleton pattern, one of the things that it allows you to do is anywhere in your code, you can go and grab a pointer to a unique object. So say, for example, the rendering, right? So let's say you've got a single rendering to screen object, right? And you want to do something, put it to screen, you can at any moment go static call, get renderer, it grabs you a pointer to that renderer, you get that, and you can start doing stuff to it, okay? That's great. It means that anywhere in your code, you can easily get to basically global single objects. The challenge is, if you are writing code where I have, let's say it's a renderer, and I have a display loop. I have display, and inside display, there's a call to texture. And inside texture, there's a call to surface. And inside surface is where I get renderer. When I look at this, it doesn't tell me what stuff it needs. It says, I'm just going to display stuff. What stuff? Stuff. I don't need to tell you what I'm going to work with. And so somewhere deep down here, it might, get world. Right? But when I look at the top here, I say, so what do I need to have defined before I call display? I don't know, because it doesn't tell me anything about the resources it uses by its function call. If the function call instead had display renderer, world, explicitly passed in to the function saying, hey, if I'm going to display stuff, I'm going to send it to this renderer, and it's going to be this world. I now explicitly know as a programmer what shit needs to be done before I go in here. Whereas with using a singleton pattern, it'll grab some random stuff later when it needs it. All right, so as a pattern, some people say, this is terrible, right? It doesn't improve your ability to understand what the code's doing. This is more explicit about what the code's doing, okay? So when using a pattern, it's not just a what I can do, can I do it, what is the pattern? It's, is that supporting what we're trying to achieve, okay? Now, for those of you who don't know C++, this example might not make sense, but another example of a kind of standard way of doing things. So in C, when you did scanf, way back in the day, right, if you were doing a scanf, so you're reading from file, say, standard in, and you'd have some stuff, and you'd have a kind of, val name age, right, whatever, right? You would scan %d, %s, %d. Okay, so this is a old style school C call, and I know in this that these things actually for scanf they probably need to be sent as make a pointer to them if they're going to be edited, because I can't pass them by value because then the value won't change, but I need to pass them by reference, and then they have a reference, and then I can edit those references and they come back and these get filled up from whatever's in here, right? old style way of thinking. Okay. C++ 14 and C++ 17 have said, no, we don't like that, right? That's wrong. That's a wrong way of thinking. R values and L values. Okay, when I go A equals B plus 6, should B change?
Value of A?
Well, no, so you know, if B equals 5, we're happy that A equals 11, yeah? After that call?
Mm.
But B should still equal 5. Right? We're not, it shouldn't be the case that both, it shouldn't be the case that B plus 6 means that B is now 11, right? That would be silliness, right? That's not at all what we mean by A equals B plus 6. No, B stays 5, got there. So, in our standard way of thinking, things that change are on the left-hand side of an operator. Things that don't change are on the right-hand side of the operator. Therefore, in your function, nothing should change in your parameters. That's bad, right? That's the wrong way of thinking. Everything should be returned from the function if it changes, right? So if you want to set name, age, so if you want to set name, you go name, age, address, equals, get details, string. This is a multiple return, right? You return a whole bunch of stuff from a function. And nothing beyond the equal side gets changed. All of that is what stays the same, and all of a sudden this side is what changes. That's the new way of doing assignment in C++ 14 and C++ 17.
And you got this only in this year?
Yeah, I know. That's why I said lucky you for doing this program. So yeah, actually, and it becomes prettier in C++ 17, which isn't even out yet. so yeah, no, because to return this, you actually still have to do a like standard call to make tuple, and then give it the 3 things in the function that you want to send back, right? You actually have to explicitly refer to the standard template library to make this thing to return it. In C++ 17, they finally decided, well, actually, you know, we know that that's what people do, and so let's create new syntax that just say, we do that, and we return that. Right? Because that's what it should look like, and it should have looked like 20 years ago, like functional languages were doing 30 years ago. Right? So no, it's taken them a while, but they're getting to the point where that
they got it. It took them a while, but they got it.
Yeah, it took them a while, but eventually they worked out that there is a better way of doing it than handcrafting your memory and editing directly to things. Now, what I mean by telling you this crazy thing about C++ and a different way of thinking is that your design patterns are often just ways of thinking. Right? Your job as master's students is to start evaluating, should we be doing this? Right? Is it the right way of thinking about the solution? Right? Rather than just, is it possible to achieve using this pattern? Right? Because yeah, singleton value, easy to achieve. Right? But is it the right way of thinking about your problem? Is it the best way of communicating to the rest of the team what we're trying to achieve? Right? Because you guys are now at the stage where your programming shouldn't be dictated by what's possible. Because we assume you've got your bachelor's degree, you can code. But anything is possible. As programmers, you can make anything. Right? So it's not can you do it, it's should you? And does this support the communication with other programs? So design patterns and professional programming line up because as a professional who is wanting to work with other people, it's not about making it work. It's about me instructing, like telling the other programmers what I'm trying to achieve with this line of code. Because if they have to maintain it, the thought behind it is more important than the speed at which it operates. Right? And you know, the modern compilers will optimize your code in ways you don't expect. Right? So all of your old thoughts about, you know, if you've ever been taught any optimization theory, you're probably the most important bit is to learn only to optimize when you have evidence that it is that thing that's slow. Right? Because you can optimize every bit of your code. Most of it is a waste of time. Right? So the key thing about optimization is testing your code to see where it's slow. The thing with design patterns, lots of them. Is it the right kind of pattern to use in this case? And maybe we as a company or we as a group of students come up with a way of doing things. We can call that a design pattern. Right? For this project, this is how you do this kind of thing. We can formalize it. Right? So rather than just relying on other people to write design patterns for us, you guys are now master students, you're at their level where you could start writing your own design patterns. You'd come up with a clever solution to something and say, right, I can actually formalize that as a standard good way of solving a particular challenge we have. Right? So when you read design patterns, don't read them just as a, oh, I'm just going to absorb all of this and it will make me a better programmer. It's more of, you know, if I was trying to do that, what would I do? Right? What problems do I have which might have a standardized solution rather than just kind of something I hack together? And can I think in communication with other team members about what I write? Okay, so yeah, I know this is we're getting there with C++. The interesting thing though is that the difference between like C++ 98, right, which is a lot of what people still learn at university level, and C++ 17 is probably greater than the difference between C++ 98 and Java, for example. Right, the change is larger. I think the change to Windows 8 from Windows 7 was probably larger than going from 7 to Ubuntu. Right? I think cognitively, the difference between Ubuntu and Windows 7, they were conceptually closer than 7 to Windows 8.
What about 7 to 10?
7 to 10, 10 has come back a bit from the whole, it's all about touch. It's kind of come back to being a normal system. But the big change, I think, is everything you do is tracked.
Yes. More spying.
Everything you do is tracked, and they ignore your proxies, and they're retrofitting it, and yeah, it becomes a different reason to select a different operating system, right? It becomes a security and kind of visibility issue, right? So, you know, even like Visual Studio, you don't have to, but it asks you to log in with your Windows user code when you start programming. What exactly are they wanting to share from me writing my own code with Windows that I should be logging in with their...
This was a funny piece of code, I want to share it.
Yes, I want to share it with Microsoft. Yeah. If you're interested in security, potentially logging in with your IDE into another company's servers and sharing data with that other company while you develop the core software you're working on for your company might be considered a conflict of interest. Right? Now, of course, Microsoft say, no, we're not sharing anything you do. We're just setting up user settings so that when you go to a new computer, you can log into your Visual Studios and it can download all of your personal development settings, right, to make the application look exactly the same every time you sit down at a new computer. Honestly, that's all we ever share. Yay, great for honesty. Yeah, security isn't really just about always trusting everybody, right? There are levels of trust that you give, and security is a lot about levels of trust you have in team members, levels of trust you have in code, right? How much do you trust a library? How much do you trust a particular line of code you write, right? So for me, this idea of including security from day one, I think is the right way of doing security, right? You should be thinking from the moment you start working on your code, what are the potential holes in the code I'm writing? Now, one solution, and for C++ people that suggested this, is, and it's a double-edged sword, is to use standard ways of doing things almost all the time, right? Unless you can really specifically think of a reason why you are using something other than the default way of doing it in the standard template library, you do it in the standard template library way, right? You don't write your own low-level memory accessing functions, because if you do, you might make a hole, right? The standard libraries are being tested more frequently than anything you write will be tested. So you're more likely to find security holes if you do things in a standardized way. There's one place you don't want to do that. Where's that? It's the most obvious place that you don't want to do things in the completely standard, normal way. No networking, you can do standard. Your validation checking. The actual security code is the only place where you shouldn't do things in exactly the normal way. Because, so for example, this happened with Android. On Google have a tutorial on how to use the licensing server, right? So they have a tutorial on, you send this to the licensing server, it sends you this back, you validate that using your local key, and then that gives you a true false as to whether or not this person had bought your product, right? Because it was tutorial code, people copied it in its entirety into their code and compiled their code and made their programs. Then hackers went in and had a look at the compiled code and looked for the signature of that particular function in compiled version. They then hacked that to always return true in the actual byte executable code. They then went to Android packages and they downloaded the code, got the executables, ran a seed on it, or added an editor, right, a patch on the executable to find this block of code that looked exactly like this and change these bits in that block of code, patch the executable. And they got about a third of all Android applications became available for them because they had used the tutorial code exactly the way it was written, same layout, same variables, everything exactly the same way, just pulled it in, used it, and so once they'd hacked it, the binary executable once, they just find that sequence of ones and zeros and hack it everywhere. Okay? Now, if you want to avoid that, and explicitly, Android, the Google says, at the beginning of that tutorial, you must change this code. This is an example of how to use these tools, but you will be insecure if you copy and paste them into your system. Right? So they explicitly told you, don't do that, and yet a third of people still did. That is one of the only places where being non-standard helps, right? Is when you are fighting someone who knows what the standard procedures are and therefore can try and defeat you on using standard procedures. Right? Everywhere else, it's almost uniformly better to use standardized ways of doing things, except specifically on high security features where going unusual might help, right? Because once you unlock those, you unlock the whole rest of the program, right? And the other things, if you break some particular part, you're unlikely to break everything if you're just doing things in the standard way. So, so security from day one, yes, you should think about what your lines are secure, and you should probably, the current advice is use the standard way of doing things that is tested and well developed. You should, in general, not trust your user to always be trying to do the right thing. Right? As a professional security person, you should be thinking, okay, well, if my user was a monkey, what might they do? Right? Dash on the keyboard, or urinate on the screen, or whatever a monkey might do to your code. One is to treat them like that. The second is to treat them like the evil genie in kind of Aladdin kind of tales, and where you rub the lamp and the genie does exactly what you ask. I want to be the richest man in the world. So he makes everyone poor and gives you one penny. Yes, John. Now, technically the richest man in the world, but it's of no use to me. Right? Or I want to be the richest man in the world, and so he kills all the other men in the world. Yay, I'm alone. Or maybe I'm the only man. That might have its advantages. But but if you treat your user like an evil genie who will take your instructions and read them in the weirdest possible way and input really strange stuff that tries to break your program, then you might be able to defend against some of the crazy that's out there, right? So security can also mean just, treating your user as someone who might put in data you don't expect, right? And so you bounds check things, you range check things. If you ask for a number and they write in the number 6. No, I said a number. It's a number. Stupid users. But you should expect them to type in a number when they ask for a number, right? Because that's what they could do. Right?
Or just word number.
Oh yeah, type in a number. A number. Right? What else did you want, right? And there's the XKCD little Bobby drop tables. Yeah. I like having semicolons in my children's name. I was hoping, I did actually discuss with my brother whether or not one of us could try and get a \n into the middle name of one of our children, right? To see what it would do to the layout of any forms that they get in the future.
\n tab.
Yeah, \n and tab. Yeah, that's just can you play? And you guys.
\r.
Yes, \r overwrite. You guys have the right to change your name. You could, as a dog, change one of your middle names to have a \n in it and just see what would happen. Just, to cause shits and giggles. But this kind of standard insertion of like what happens when you put in additional characters, a standard security way of thinking, and you see this, they're still trying to fix this kind of stuff, is that instead of saying things like, oh, I trust this string to have valid commands in it, I will run whatever in that string. You write all the valid strings yourself, all the valid strings you can ever think that you ever want to use. You just spend the extra few moments, hours, whatever, writing them all out. If you've got years worth of instructions, then that's a lot. But you write them out and you make the user choose one of the ones you've stored, the stored procedures, rather than let them run their own code. Right? It's a standard way of thinking. So a standard, like for kids animation, so for kids MMOs, right? So there was the Penguin one. What was the Penguin MMO for children called? Club Penguin.
Club Penguin, yeah.
Had Penguin. Club Penguin was a game, MMO for kids, right? So what's the TTP for an MMO for kids? Have you heard the phrase TTP before? No. Apparently this is a primary school term, TTP. When you give a 14-year-old boy any tool, how much time to penis? Because that's what 14-year-old boys will do. Any tool you give them, they will draw a penis using that tool at some point. And they look at how long it takes to go from not having anything to drawing a penis. Right? So in Snapchat, that went pretty fast. If you randomly chat with people, you're going to see some pretty disturbing stuff. So The TTP is if you're trying to protect kids from people having inappropriate conversations, how do you protect them? Well, there was the mode that instead of having free type text communication, like you would in an MMO, where you send text messages, you have them select from a set of acceptable commands. Right? So they went through and thought, well, you know, what do kids talk about? Right? So what you do is you go to a normal school and you record, you know, a few days of conversations, and you find similarities in those conversations, and then you just give people a selection of things to say and a selection of potential answers that kids actually use, and then instead of free typing, they type in one of those selected phrases. Right? And that was their way of trying, basically whitelisting instead of blacklisting. Instead of making individual statements illegal, like you can't use the word sex, because, you know, when you come from Essex, that's an illegal word because it's got the word sex in it. Right? Yeah. Blacklisting is not so great. And, you know, what's the standard way of getting around I can't use the word sex? What do the standard spam do? You can all read it, but, you know, if I blacklisted just the combination, then how do I blacklist this? And what if I, you know, do SE_X? Can you still read that? Yes. How many combinations of this would I need to blacklist before I got every single one of them?
You also got like special characters like he with super things or
yeah, and greater than less than. Oh, come on. Blacklisting as a security policy is hard work. Right? Basically, it doesn't work with words, right? People find a way around it. And so when you're thinking about writing your code in a secure way, one way of dealing with the thought is to say, okay, is it possible for me to work out what the whitelist is? What am I going to let my users do? Is that list exhaustive? If I can't, if I kind of spend some time and I can't get a full list of everything I want my users to do, all the features I want to provide as an API script to my scripters or my outside developers or whatever, then how do I minimize the amount of damage they can do by still giving them enough flexibility to do all the things they need to do, but then checking that they're not combining things, right? So can I just get all the combinations? Can I whitelist this group, and this group, and any combination of those, right? So are there ways that I can combine whitelisted things to create a broader list, right? Rather than just, oh, I'm gonna check so that they don't do this, right? So it's a different way of thinking. Okay. So security, if you think of, not security by security, but kind of a whitelisting, how do I program in standard ways for most of my code so that it's well checked and the normal way of doing things? It probably also helps with communicating what you're trying to achieve, because if you're very clear about what you're doing, then it's easier to check if there are holes. One of my professors, when he told me when I was a second year student that I should always program as if he was looking over my shoulder, right? Which was a bit freaky to think, you know, he's always there over my shoulder. But a kind of not quite so creepy way of thinking about it is you should always program with the intention that someone will maintain your code, right?
Someone else.
Someone else will maintain your code, right? And in the sense, another professor I had, the assignment he set was, you know, it was graphics. You write the code to do this task. When you submit it, if it doesn't work, you lose marks for every minute he spends fixing your code. Right? So instead of just giving you, like, it didn't work, he will go in and fix your code until it does work. But the longer he spends, the more marks you lose. Even if it was just a very simple error, because it takes him a long time to find that simple error, you're going to lose all of that time and marks. right? Until, you know, he'd spent sort of the 30 minutes trying to fix your code, right? If your code took more than 30 minutes to make, you failed, right? But if he could fix it within 30 minutes, you'd be losing like 3 marks a minute or 2 marks a minute as you went down for every length of time it took him to fix it. And so when you code, your intention is to say, okay, if someone was coming in here because there's a fault in this code, what would be the fastest way they could find that fault? Right? If that's your thought process, right? Because professionalism isn't really about just what you do, right? It's not just a thing, it's about the way you think. It's your approach to your code and your approach to your solutions and your approach to each other is a professional approach. You are thinking, how does someone else maintain this code? How do I write this line of code so that when someone else reads it, they know what I'm trying to do? Right? So everything from little tiny things like initializing things, right? If I initialize, so if I went, float, say height, right? If I do height is a float, okay? Now, technically, we should also initialize this, right? And I can say float height equals 170. Okay. Now, technically, there's a cast in here because that's an integer and this is a float. And so it casts that into a float and then puts it in here. Okay? Which the computer will do for me. Okay? And if I didn't initialize it here, I could have done later on some sort of, you know, height equals 170. Now, the problem with this bit of code is it has that implicit cast from int into float. So it would be better if I actually explicitly said 170f, right? I explicitly say this is a float, right? Even though I know I could just say 170, I just say it as a float. And I try and make my code more explicit. So if I have a pointer, I don't initialize say, if it's a float pointer, right? I don't initialize it to 0, even though I know I've got a macro that defines null as 0. Right? I know that null is 0.
Use null pointer. Null pointer.
And yeah, knowing null pointer, I know null pointer is defined as 0.
No, the actual.
No,
there's
the
a
standard, the new one.
So when you do, if you actually create that standard null underscore PTR, is that right?
You don't need the standard thing.
Okay.
Just type null PTR.
Yeah.
There we go. That explicitly says this is a null pointer, right?
And it isn't null, like the 0.
And it isn't, this is no longer, it's no longer equals 0. It used to be that like null, you usually have null equals 0 because they treated a null pointer as 0. And you see people set, you know, knowing that null was 0, they would set a pointer that was pointing nowhere to 0 because they knew that it was 0. But that fools me into thinking this might be a number, right? This might actually be something that I could have set to 1. If you set it to 0, why can't you set it to 1? Well, because it's a pointer. And so no, setting it to null pointer is actually that tells you what it's doing, right? It's more explicit about what I'm trying to achieve. If you mean ++ to increment, if you have an A and you are incrementing A, right? Or that's if I say yeah. So if I'm going to do an increment, right? You don't do A + 1. Why is that better than that?
Less error prone, maybe? Like,
that is a number. As a programmer, a number could be a number. Why isn't it number 2? Why isn't it number 5? Why isn't it number 7?
magic numbers.
Right? It could be a magic number. This can't be anything other than direct increment. Right? So it's not saying add something to it, right? Which is what the plus does. It says, no, you are incrementing. It's a different kind of thing. Right? When you write code, if you write code and you happen to know that you're using a screen width of 700, right? Nowhere do I want to see the 699. 699 should never appear in your code. Right? If you know there's something you want to do one less pixel than the screen width, you say screen width minus 1.
Yeah.
Right? And in fact, you do screen width minus buffer. You say what it is you're doing. You don't just write the magic number in.
Also makes it easier to change.
It makes it easier to change because you've got these two things you can go and change, right? But this assumes a whole bunch of stuff, right? And it makes it, if I'm looking for the number 700, I'm not going to find 699, right? So that's why I never want to see that. If I even need half screen width, if I need 350, I never want to see 350 written in your code. If your screen's 700, you never write 350. You only ever write 700 divided by 2. Or even better, have a function half screen width, which returns 350. Right? Because this is describing what you mean. You want half the screen size.
Whatever it is.
Whatever that is, however, but that's because this is more explicit about what you do. If you start writing number 350, what if you wanted a third of the screen? How am I going to find that? Do I have to find every possible fraction of my screen width as a magic number somewhere in my code, right? All of that is really unprofessional in terms of coding stuff. Okay. The last thing, so what's the time?
Yeah.
Yep. The last thing I was going to talk about, because I've got to go to another class, is code reviews. What is the practice of code reviews? Okay, so when you write code, there is a tendency for students, like when you write poetry, right? I don't know how many of you write poetry, but if you write poetry, a bunch of people don't really want to share their poetry because, it's not good enough. Now, people often feel the same way about their code, right? They've hacked something together and they don't want to show it because, it's pretty bad code, right? Because we all know that, we're under stress, you write bad code. The only way to really get it better is to show it to other people, right? Because even if you just show it to yourself, right, and you review it yourself, you might not see the big flaws in your code, right? Other people might go, what's going on there, right? Why have you got, like player.age equals 5? What are you doing with this function? What? You're setting a function value? And you say, oh, yeah, no, because I know age returns a reference to int, so I can do that. And you go, why? But that's so ugly. Don't do that, but I can. No, don't do that, right? Because that's not what this is supposed to be, right? So when you do code reviews, you will have people find things which you've done which they don't like. I back in the 90s. Okay, so I've been programming a long time. I can say back in the 80s when I was programming because I started in '84. So I've got some bad code in my past. You can write, or you used to be able to write, and I don't know if they've changed it, but A times B greater than 0.
Yeah, I can still write that.
Yeah. what does that do?
If b is greater than 0,
Then we will get A.
you'll get something. If it's not, then you'll get a 0.
Yes. A equals A times. So I could then do that because, you know, I can do star equals. This is still legal code. If someone wrote A star equals B greater than 0, what would your mind wouldn't immediately go to saying that is equivalent to A equals B greater than 0, question mark, A 0.
Yeah.
These two are functionally equivalent. This is more efficient. Why is that more efficient? There's no branching. This is a multiply. You can stick it in the pipeline and just stick more numbers in your pipeline because there's no if branching statement here to decide which side you should go on. Is this ever the way you should do it? No, just because I can doesn't mean I should, right? This is not a professional way of communicating what I'm trying to achieve. Right?
Is it casting?
Oh, that's a whole bunch of shit going on there. But yeah, so, but I know, I actually did that in my code. A times B greater than 0. That's code I used, right? And I used a lot of it because I was doing neural networks and I was using this as the activation function and I was using this as the weight to the next neuron. Because when you get a neuron and you have a threshold function that then activates a connection, when this is true, how much weight does it send down? Well, it sends down the weight on that network. So A times whether the threshold was above was a perfectly normal way to think of it. That's how I thought about it. Code review, yuck, don't do it like that. I said, but it's efficient. No, I don't care it's efficient. It's really disgustingly ugly. Code review catches that sort of shit and stops it happening, right? So what we do is we put the code up on screen, you stand up next to it, and you start explaining your code, and people go, yeah, I think maybe we need to look at refactoring this bit because those functions don't go with those other functions, right? Or why, like you had to explain to me 3 times what that code was doing. You need a better comment, right? So that's the kind of, when you put it in front of someone else, you get that feedback. Right? And we expect you guys to do that with each other. Right? We expect you to be doing code reviews where you show the rest of your team what you've been coding. Right? Hopefully, we can get a chance where Marish and I, or Brunner, or Tarja, or any of us get to stand up here, look at some of the code you guys have written, and go, okay, yeah, not the way I would have done it. Let's work out what exactly are you doing here? Why have you used that name for things? Right? Now, if you've got a coding style, it could be you've got an acceptable coding style and you've worked that coding style, and that's the reason you've done things in a certain way. And it may be that's fine. It may be we say, well, actually, no, that's not. There's a better way of doing that by communicating it in this way, and then change the code. Right? So code reviews are an important way of improving your code. It's showing it and being honest and letting people see your bad code as well as your good code. Right? And this is probably as much about professionalism and security and design plans and code review, honesty with your team members about your code. Right? Be honest. If I tell you honestly, I didn't do a good job of that. Right? Or I think I've written some pretty, it works, but I don't think it's very good code. Right? It's far better to be honest and tell people where you're at. If we've got tasks to do and you haven't done your task by the end of the week, and you say, oh, look, if you say, oh yeah, I got it done, thinking in your mind, oh yeah, I'll do it tonight. Yeah, I'll just do it tonight, right? And they say, okay, well, you know, this is what the work for the next week is, and you can have this and this and this. And one of those things rely on what you said you've completed. And I pull the repo as it was when you said it was done, and I start building from what you said was working. And you find later that you had to change the input to that function because you needed another piece of information to implement, and you lied to me and told me it was done, you've just screwed over my weekend. Right? Now, that's just not nice, right? You shouldn't lie to me, right? If you haven't done it, you say you haven't done it and we fix it, right? But if you lie, you fuck things up for everyone, right? So as a professional programmer, you need to be honest with where you're at with your team, right? Customers, maybe not, right? It depends, but with your team, because you are now a team, right? And in these projects, you're a team, you're honest with your team. Right? If you haven't got something done, you say you haven't got it done. Right? And then we plan from the current truthful situation, not from some freaky ass lie that you've made up that, oh yeah, it's done. It's done. Honestly, I know it's done. In my head, it's done. Because the other thing is, when you work as a team and work out like how much time you've got left to implement features, you secretly adding another 5 or 6 hours of stuff you haven't done yet to the schedule means that I'm going to give you more work than you could possibly do in our schedule, because, you know, I'm thinking about what's reasonable given the state we are in. That's why it's agile. That's why we try and do this whole agile thing, is needing to communicate a lot and be honest, okay? So if you take one thing away from us talking about design pattern security, I would take honesty and communication, right? You have to talk to your team. Design patterns are talking about team, code reviews are about talking with the team, professional programming practices are about good communication about what your code is doing. Security has a bunch of, if you don't know how it works, it might be insecure. So communicating with each other helps your security as well, right? So communicate and be honest in your team, and you're likely to do a better job than if you kind of don't talk to each other or try and say, oh yeah, no, I got it done, and when you haven't. Any questions? So I haven't really told you anything about individual patterns or really how to be like what is an example of a professional, but it's the ideas, it's the principles that I want you to try and remember. Okay, that's the important thing. Okay, okay. Well, have a great Friday, and I'm going off to talk to my second years now. Bye, internet. I will see you in the future. Okay, good. Okay.
Yep.
Hopefully they'll watch that and be uninspired.